Effects of heat. In this lesson, we are going to learn effects of heat. Thermometer. A thermometer makes use of the property of the expansion and contraction of substances due to heat. Generally, mercury is used in the thermometer for the following reason. First, there is a big difference between the freezing point and the boiling point of mercury. Its freezing point is minus 39 degrees Celsius and its boiling point is 357 degrees Celsius. Second, it is shiny and can be easily seen. Third, it does not stick to glass. Fourth, it expands regularly and uniformly in all conditions. Construction. A glass tube with a uniform bore is used to construct a mercury thermometer. It has a bulb at one end, filled with mercury. The air in the tube is removed to create a vacuum in it, and the other end is sealed. To mark the scale, the bulb of thermometer is placed in ice, and the level at which the mercury settles is marked at 0 degrees Celsius. Now the bulb is held in steam coming out of boiling water. The new level of mercury is now marked as 100 degrees Celsius on the tube. The distance between the two marks is divided into 100 equal parts. Each part shows a difference of 1 degree Celsius. Temperature of a furnace. We cannot use the laboratory thermometer to measure the temperature of a furnace because its temperature is about 1000 degrees Celsius. A different kind of thermometer is used for this purpose. It is called a barometer. Baro refers to fire. This thermometer is made by joining together two different metals like copper and iron. The metals to be used are selected on the basis of the temperature to be when one end of the combination is held in the furnace and electric current passes through it. This electric current is measured to obtain the temperature of the furnace. Measurement of heat. Students, let us perform an activity to study that when equal heat is supplied to different substances, the rise in their temperature is different. Take 200 grams of water in a beaker. Take 200 grams cooking oil in another similar beaker. Measure the temperature of the water. Now, place it on a stand and heat it. Stir the water occasionally. Stop heating after 3 minutes and note the temperature of the water. The difference between the two temperatures shows the rise in the temperature of the water in 3 minutes. Now, carry out the same experiment with the beaker with oil. Heat this beaker also for exactly 3 minutes. Note the rise in the temperature. We find that the rise in the temperature of oil was greater than that of water even though the heat given to both the liquids was equal. When equal heat is supplied to different substances, the rise in the temperature is different. Or, if we wish to see an equal, say 1 degree Celsius, rise in the temperature of equal masses of different substances, different quantities of heat will have to be given. The heat required to raise the temperature of certain mass of a substance by 1 degree Celsius is called the heat capacity of that substance. Specific heat. The quantity of heat required to raise the temperature of 1 kg of a substance by 1 degree Celsius is called the specific heat of that substance. The unit of heat. The quantity of heat required to raise the temperature of a substance depends upon the substance, its mass, and the rise in temperature. This principle is used to define the unit of heat. It can be measured in calorie and the kilo. Once you understand the two terms, kilocalorie and specific heat, it is easy to understand that the specific heat of water is 1 kilocalorie per kilogram per degree Celsius. A study of many liquids has shown that the specific heat of water is greater than that of other substances. Sometimes, if it is more convenient, the unit calorie may also be used. The quantity of heat required to raise the temperature of 1 gram of water by 1 degree Celsius is called a calorie. Calorimeter. The heat given by a hot substance or the heat taken by a cool substance from a hot one depends upon the 3 factors. First, the mass of the substance. Second, the specific heat of the substances. Third, the difference in the temperature of the substances. These factors can be used to find the specific heat of a substance. A calorimeter is used for the purpose. A calorimeter is a cylinder copper container placed inside another container. The space between the 2 containers is filled with a bad conductor. It has 2 holes. A stirrer can be inserted through one hole and the thermometer through the other. A measured mass of water is taken in the calorimeter and its temperature is noted. The substance whose specific heat is to be found is heated to a certain temperature and then added to the water in the calorimeter. The water is stirred and the final temperature of the mixture is noted. From that, the specific heat of that substance can be calculated. Summary. The quantity of heat required to raise the temperature of 1 kg of a substance by 1 degree Celsius is called the specific heat of the substance. Calorie is a unit of heat. A calorimeter is used to find out the specific heat of a substance. So, that is all in this lesson, students. Learning is a fun, so keep learning.